practice set 8, unit 8, 7, rigid transformations. We talked about this today. Rigid transformations are translations, rotations, and reflections. Why? Because when the pre-image, and let me go back here, the pre-image, which is this one, right, the original image, gets reflected, translated, or rotation to that, right, all the corresponding sides and angles will have the same measurement. Meaning, let me highlight side AB. Side AB, it corresponds to side A prime, B prime. Notice that those both two sides are 2 units. Side AD and side A prime, D prime also have the same length. Okay, so when we talk about rigid transformations, you're talking about a shape that got reflected, translated, and rotated, and its image has the same length and the same angles. Okay, yeah, that's it. There's really not much to this. So let's do some of these problems. All right, here. Is there a rigid transformation that can move this guy to this guy? Absolutely not. All right, so in order to be rigid, both shapes have to be exactly the same, maybe in a different position, but the lengths have to be the same, and the angles have to be. The shape has to be exactly the same, just like I said, maybe rotated, reflected, and this, there's no way this will turn into this, right? The pre-image will definitely never ever look like the image, not through a reflection, not through a rotation, and not through a translation. So this was definitely not a rigid transformation. It could be something else, but it wasn't a rigid transformation. This one, how did the shaded triangle, is there a rigid transformation that would take the shaded triangle to the unshaded? Right, now this one is easy, right? So definitely if you look at those triangles, they're exactly the same. So definitely it was either a rotation, a reflection, or a, what's the other one? Translation. One of the three moved the original triangle to the pre-image to the image. In this case, it was a translation. Okay, so was it a rigid transformation? Yes. Why? Because all the lengths, all the angles, it's the exact same shape. Right? Determine whether a rigid transformation can move the shaded figure onto the unshaded. If so, describe the figure. So there is no way a rigid transformation can take this rectangle to this. They are not the same. Okay? No rotation, no reflection, no translation will ever make this shaded figure look like this. So this is a no. This one is a yes. It's the exact same shape. If you look at the corresponding side, does this side and this side have the same measurement? Does this side and this side have the same measurement? Is this angle, well, they have all 4 angles here. Are these 4 angles exactly the same as these 4 angles? Yes, they are. So in this case, well, it was a rotation, first of all. And a rotation is a rigid transformation. What about these two? This is a yes. It was a rigid transformation. Which one? A reflection over a vertical line? Yeah, that I can't draw. Right? So a reflection over a vertical line, and this is a rigid transformation, right? Because everything is exactly the same, the side length. This one, how did the pre-image become the image? It was definitely not through any of the rotation, no, the rigid transformations, rotations, reflection, translation. So this is a no. This one, triangle ABC, A prime, B prime, C prime is a image. So we went from this to this. Okay, it looks like it was a rotation. Notice that A is here and A is now over here. Rotation of 9 degrees. What is the length of BC? Well, BC is 4. B prime, C prime. So this side, by the way, corresponds to this side. Right? So they're saying it was a rotation. So a rotation is a rigid transformation. So if it's a rigid transformation, guess what? Everything is the same. So BC was 4, B prime, C prime is also 4. What is the measurement of angle B? Where's angle B? It's right here. Oh, and angle B prime is over here. So because those two angles are the same, 52 degrees. What's the measure of angle C? Well, angle C prime is 50 degrees, which means that the angle C is also 50 degrees. Here, we had this guy here, line segment AB, and then obviously a lot of things happen to this angle, line segment AB. So here's AB. Line segment CD. Is line segment CD, is there a way of making AB look like CD? Yeah. We can rotate it, right? Is it the same length? 1, 2, 3, 4, 1, 2, 3, 4. So this one is okay, right? Again, remember, same exact image, except that it's been translated, rotated, or reflected. So AB can definitely be CD. Line segment KJ. Look at KJ. KJ is shorter than AB, so AB, there's no way AB can become KG through reflection, rotation, and translation. So this one is no. NP. What the heck is NP? NP is right here. It's 1, 2, 1, 2, 3, 4 units long. AB is 4 units long. It's through a translation, right? Move down and then to the right, so we're good here. Same length. LM. LM is definitely bigger than AB, right? So it is not, AB did not become ML through a rigid transformation, right? Because it got longer, it's not the same length. So that's gone. GH is 1, 2, 3 units long. Notice that GH and AB are the same length, so therefore yes, and it's through a rotation and then a translation, so this is okay. Line segment EF, notice that it's smaller. There's no way AB became an EF through rotation, reflection, or translation, so that's and then finally we have, whatever this is, spiral review. Means what's the area of the rectangle? Well, area is defined by the number of square units inside. You can count 1, 2, 3, 4, 5, 6, 7, 8. Multiply the length and width. 2 times 4. Either way, it's 8 square units. What's the perimeter? Really? That's the spiral review. Perimeter is the distance around this figure, so it's 2 units this way, 4 units this way, 2 units up, and another 4, so that gives us 12 units. Reflection, that is up to you to do, okay, but that is your practice.